Hello and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. Hello and welcome back. It's amazing to be back, and I'm so happy to be launching the rebranded show. The format is going to remain the same, so we're going to have interviews with experts from the industry, also with some key topical items from me as well mixed into that, and you'll have noticed we've now got this snappy new intro. You will have noted the new brand and the name for the show, and basically the reason for that is because I've exited Avid. So I've sold the business now, and I've moved on to new ventures. I wish Turntide, the company that bought Avid, all the best. It's fantastic that they've been able to bring Hyperdrive and Avid back together into one stable again, and also bring that huge investment to the northeast of England. So what about me? Well, I'm working with some really exciting companies now in the EV and power electronics space. I've been helping to create an amazing new power electronics, motors and drives research and development centre right here in the Northeast, and I'll have more on that for you in a later episode. I'm also working with a really exciting company who have a novel torque sensor technology that we can apply into electric motors to help improve efficiency, safety and reliability, and I've got more on that coming in a future episode as well. I've been helping to develop a semiconductor business, and that's a really exciting space at the moment. Obviously, lots in the press with semiconductor shortages and things going on in that space, and we've got some really exciting technology there. And I'm also working with some major vehicle tier 1s to right down to smaller companies, but all in the EV space, helping people with product strategy, development, technology commercialization, and business scale-up. So, in the EV world, and in fact in the world in general, an awful lot has happened since I last released an episode. Just when you think there can't be any more big news, there's another huge release. And it got to the point where there was massive releases every week. It seemed to quieten down a bit, but it feels like it's coming and coming and coming more and more now. Way back in podcast episode 8, so when we were just getting started, I did a whole episode about the benefits of MultiMotor Drive systems. All the way back then, there really weren't very many cars that were offering that in production. So you had some pretty exotic stuff where there were multi-motor drive systems, like the Rimac, the Concept 1, that used 4 motors, 1 on each corner. The Neo EP9, again, multi-motor drive system. But on normal cars, or even sort of high-end normal cars, it wasn't really a thing. But we've now got vehicles coming into the market which are much more conventional. So in the US, you've got Rivian with their pickup trucks and SUVs. They use a multi-motor system. Tesla on the Plaid model, that's got 2 motors at the rear, 1 motor at the front. So that's getting in now into that sort of full multi-motor space, torque vectoring from that rear axle. And there are many, many more vehicles coming. There's a really interesting hybrid car from Honda that's got 2 motors in the front. Again, they're using the torque vectoring. So it's now becoming a much, much more common thing. So recommend if you're interested to learn more in torque vectoring. I'm not going to repeat all of that again, the benefits of multi-motor drive, so go back and look at episode 8. I'll put some links down in the notes below. I think one of the more important vehicles to have been announced recently is the Ford F-150. So that might have a few people go, oh, what? Why is the F-150 important? Well, the F-150 is important for a few reasons. First of all, it's one of the most popular, best-selling vehicles in the world. And it's hard, actually, as a European to kind of recognize that because we don't get them over here, or certainly not in the UK anyway. They're quite an unusual sight. But obviously in the US and South America and other parts of the world, F-150s are really, really common sight, and particularly in the US, where it's actually the most popular vehicle, bar any, which is sold. So F-150, it's absolutely massive. It's part of Ford's new... Literally, it's a massive vehicle, but it's massive news because it's such a huge part of Ford's product lineup. And for a long time, actually, to be honest, Ford weren't really getting it, or didn't seem to be getting it in terms of the EV space. But now, I guess you could say with Tesla going with a Cybertruck, you've got Rivian coming, want to eat their breakfast and their lunch and their dinner. Ford really have had to do something. So they've launched the F-150, and it's really interesting. The drivetrain on it's interesting. The performance is interesting. They had the US President, Joe Biden, in it, made a real big splash with it. It's the first Ford pickup truck to have independent rear suspension. And basically, they've done that to make it easier to engineer in the electric drive unit, which is going to be mounted solid to the vehicle frame. And that's quite a big difference. Normal pickup trucks don't have independent suspension. Obviously, the Rivian does, but that's not exactly a normal pickup truck. Normal pickups don't have independent suspension. They tend to have a solid axle. And you can get e-axle units, which we're starting to see more and more coming in commercial vehicles. And really interestingly, Magna recently showed and launched an e-axle for this kind of size of pickup, so like the same kind of size that the F-150 is, and those kind of size of commercial vehicles. Now, I had thought initially that this might have been going to go into the F-150 when I first saw it. Magna, not normally the kind of company who launch speculative things like this. So I would say they've probably got a really clear initial target application and customer that they're developing that for. So it's going to be interesting to see who goes with that solid e-axle in a battery electric pickup. And it'll be really interesting to see how that compares to more conventional, I'm saying conventional, so totally unconventional for a pickup, but more conventional for an EV, the independent rear suspension, which is much more car-like in its in engineering and how it works. So I'm guessing whoever decides to go for that e-axle is going to want more of a sort of utility. They don't want to sacrifice any of the utility of the pickup truck by going for that independent suspension. So it's really interesting to see what's happening in that pickup truck space, which is like, anyone who knows anything about pickup truck drivers in the US, a lot of people use them. They're work trucks, but then a lot of people have them as kind of a leisure vehicle, and they use them to tow boats and jet skis and all sorts of stuff like that. It's such a big market in the US, and it's really, really fantastic to see that market now going quite quickly towards electrification. Also, back in an old podcast, in episode 51, I talked about the emerging trend to go towards 800-volt systems. And since then, we've seen quite a few really interesting new vehicles come to the market with 800 volts. So again, 800 volts came in. The first sort of proper production vehicle to use it was the Porsche Taycan. They went to an 800-volt system. Obviously, some higher performance vehicles were up around that kind of 800 volts before then, so some pretty exotic stuff. So not a full battery electric, but the McLaren P1 hybrid, that's about 650 volts, which is in the kind of same territory. The Rimac Concept 2 is up at the 800 volt sort of level. So, it's only been on proper super exotic stuff, but now we've got a couple of new really interesting cars from Hyundai, which have gone for that 800 volt architecture. Now, if you look at EV efficiency and kind of range and performance and stuff like that, Hyundai do really, really well. So, they don't make cars with huge batteries. So they don't have anything that's up, with a 100 kilowatt hour battery like a Tesla or anything like that. They tend to be more sort of normal, lower cost vehicles, more sort of typical battery size, 55, 65 kilowatt hours, that kind of thing. Maybe a little bit bigger in some of the cars. I know if you're listening, shoot me down exactly with the exact specifics. I'm not a super expert on Hyundai's cars, although I know they're not making huge batteries. So they've got some good cars with some good batteries, and their ranges are always really, really good because Hyundai have been super focused on system efficiency. So they did some clever things before other people were doing them. So they were using heat pumps in the heating system in the car to make it more efficient, and doing some other things that were really, really interesting to improve the system efficiency. Obviously, all the Tesla fans will say, "Oh, Tesla are loads more efficient," but Hyundai definitely been one to watch in terms of the more conventional cars, and really nailing it with the efficiency. So it's really interesting to see Hyundai go for that 800 volts. And I can tell you that's all about driving efficiency in the vehicle. So 800 volts gives you more voltage, but that for the same amount of power, you can have a significantly lower current. Now, less current means less copper everywhere. So you can have smaller cables, smaller connectors, which are obviously lighter. They can be cheaper, although they've got to be a higher specification to deal with a higher voltage. But you can also have less copper in the motor as well. So you can take weight out of that. You can get the efficiency up because the current losses are less. So anytime you're passing current down an electrical conductor, you have what are called ohmic losses, and those losses are I squared, so the current squared times the resistance of the conductor. So if I double the voltage, so if I go from 400 to 800 volts, I literally half the current. So the current is halved. And because the losses are proportional to current squared, that has a much bigger impact overall on the efficiency of the system. So higher voltage vehicles coming through in more conventional applications is a really, really interesting thing. And I think we're going to see much, much more of that as more EVs start to come on the market and more of them kind of start to push ahead with the technology. So across in the commercial vehicle space, there's also been an awful lot of things happening. Now, fairly recently, there was a big change in legislation in Europe, which meant that commercial vehicle manufacturers were going to have to deliver CO2 savings in the same way that passenger car manufacturers have had to for many, many years. And basically, in the passenger car industry, that led a move from conventional petrol engines to diesel engines, common rail systems, gasoline turbocharged engines, direct injection gasoline engines, etc., etc. Now, in commercial vehicles, obviously, you've already got really quite efficient turbocharged diesel engines in pretty much every truck. So the only way to get anything any more efficient there is by doing some sort of electrification. So what you've got happening in a lot of trucks at the moment, and the new trucks coming on the market where they're doing elements of hybridization, so things they have not done before, where they're using electric drives, either as kind of like a mild hybrid system, so they're fitting bigger alternators and more electrified ancillaries on the vehicle, or going for full electric drives. So we've seen recently product launches from lot and lot of truck makers with fully electric drive systems. And of course, the more controversial of the whole lot, but we've still seen it, recently, obviously the Nikola and everything that happened there, but you've still got Nikola and CNH, so the Iveco brand, working together to launch fuel cell trucks as well as battery electric. And still companies like Daimler working quite hard. So Daimler recently, like in the last week or two, was showing a fuel cell truck and talking about the performance and the things that could give you. So, fuel cell systems, somewhat controversial in terms of their efficiency and obviously a lot more complex than a battery electric system, but allowing you to carry more energy on board and having some other advantages. I think actually it's one of my pet topics, but a lot of the advantages of a fuel cell system actually are nothing to do with the truck itself and the energy you can carry. It's more about the infrastructure. So one of the biggest challenges is even, let's say a delivery company, so the trucks are going in and out of the same place every day, but a typical truck depot could have 100 to 200 vehicles running out of it. That would not be unusual for a haulage company. And if you've got a lot of trucks running with big batteries that need a lot of charging power, that's actually going to cause you a huge issue in terms of the grid connection. We've got one thing, charging cars at home, one car charging at a time with 7 kilowatts, and you maybe need to charge it a couple of times a week. And, that's fine. Obviously, there are challenges with that, and the grid and infrastructure needs a bit of upgrading. But if you've got 200 trucks running out of a depot, and they've got like a 500 to 600 kilowatt hour battery pack, even if you can allow them to charge overnight, that's still a huge amount of grid connection that you need to charge those vehicles. So in that case, you can fit batteries to sort of buffer the grid and do stuff there, and there are lots of people doing really interesting stuff in that space. But at the same time, that's expensive and it's more battery power and all that kind of stuff. So fuel cell vehicles allow you to kind of buffer that grid connection in a much bigger way, with potentially lower sort of infrastructure costs. And again, the sort of jury's somewhat out on that. So I'm sure people will have something to say about that from it. But it's really, really interesting to see all the stuff happening in the commercial vehicle space, and some of that's driven by legislation, but the market in general is definitely going into electrification headlong. And we've got some really good interviews coming up with people who are absolutely in the heart of that space, some real technical experts, technology experts from that field. So then we've got lots of new investment companies. I've mentioned the huge batteries that you need in a commercial vehicle and the grid storage side of things. And actually, in my patch, so I get this shout out. So I know, people are listening to this podcast all over the world, and I see the user statistics, and, thank you for taking the time out. But a lot of you will know I live in the northeast of England. That's why I sound a little bit unusual. So those of you who've complained about my accent or how I pronounce things in the past, I have quite a mild regional accent from the northeast of England, but we are quite ahead in terms of the electric vehicle space. So, obviously in the past have been startup companies like my own business, Avid, and then we span out the Hyperdrive company, and we had Sevcon, who a lot of people know from, one of the oldest electric vehicle drives manufacturers in the world, going right back into the 1960s, where they were making drives for milk floats. But we also had some pretty amazing engineers working in the Northeast, 100 years ago, developing things like steam turbines and sort of high power electrical generators. So Parsons and folks like that. So we've got a long history in the region. But we also had all the coal and coal-fired power stations. So it's been fantastic to be able to welcome Britishvolt to the region. So they are a new company that have sort of come onto the scene, and they plan to build a huge battery gigaplant on the site of the former coal-fired power station, which is actually in a place called Camas. So Camas is a little bit of an unusual word, Cambois, Cambois, but you pronounce it Camas. In Northumberland. So it's the power station that it was replacing was Blythe Power Station, because it's on the River Blythe. Across the river from Camas and from the power station is the town of Blythe, but it's pretty important, particularly if you live in Camas, to not get them confused. So the new gigaplant is going to be in Camas on the site of the former Blythe Power Station. And for me, it's just fantastic to see that happening. I spent quite a lot of my childhood in Camas. I know that place pretty well. My family are from that area. My parents met there, et cetera, et cetera. So, being able to see this really positive change in that area is just fantastic. One of the reasons that that location was the preferred choice was because it had this huge grid connection. So I talked about the need with a commercial vehicle depot about the grid connection. So getting new grid connections of any sort of sizable power is really expensive and a lengthy job. But because there'd been a power station there in the past, the power station got knocked down, I think 15, 16, maybe 17 years ago. They actually left, though, the transformer shed, and there'd always been plans to develop the site and add kind of offshore wind turbines and such like, where the transformer shed would be able to be a connection point into the grid. Since then, that's happened, so there are offshore wind turbines in that area. We've also got the North Sea interconnector, which has just started working, so that's a link all the way across to Norway that can bring in electricity from Norway under the sea. That's quite an interesting infrastructure project in itself. I believe it's a high voltage DC link rather than being an AC link, which is what a lot of them are. So there's a big shed right next to where the Britishvolt plant will be, which is basically a giant DC to AC converter. They're putting the power on the grid. So the Camas site was pretty unique in the whole country because it had the transformer shed and the energy infrastructure. It also had a great road infrastructure as well, because of the history of that area with coal mining and such like, the roads and things are pretty good around there. So they weren't going to have to put in a huge amount of infrastructure. They can get up and running more quickly. And that's really, really important at the moment. We need extra capacity coming into the industry to support the growth. Hot on the tails of that, so, as if that wasn't enough, it's a massive battery gigafactory, one of the biggest that's been announced so far. We also have recently had, so very, very recently, Nissan announcing mega plans. So they have this thing called Vision 360, and along with their battery partner AESC and Vision, they are going to build an additional battery gigafactory next to the Nissan car plant. Nissan are bringing a number of new models through that plant. So there's hybrid stuff and there's battery electric stuff. And there's a huge investment going in there. And it's really, really fascinating. I'll put some links in the show notes to the Vision 360. It's a brilliant thing that Nissan are doing. Huge fan of their products. So great to see that happening. But lots of negatives going on at the moment as well. So obviously we've had the whole COVID situation, which has still hasn't left us, still kind of lots of issues going on in schools and universities and stuff with COVID. We've got a lot of problems in the supply chain, which are partly COVID related, but also partly related to other things. So in the press, in the UK at the moment, and a lot of other people are laughing at us for this, but we've got a problem with lorry drivers. There's fuel shortages and such like, and there's some issues there. Now, the truck driver problem has been one that's been brewing for a long time. And if you've ever spoken to me about it, my father was a truck driver, so appreciate it's a really tough profession. It's a difficult profession. You're away from home if you're doing long haul stuff. Basically, they're paid terribly. The companies that run the trucks actually treat their drivers, generally somewhat poorly. And particularly in the UK, a lot of other countries provide good facilities for truck drivers to park up in and get a shower and stuff like that for free. Whereas in the UK, if you've ever noticed motorway services, they've got paid quite a lot of money to stay in the motorway services. So next time you're in the motorway services, you will notice that most of the trucks that park up overnight tend to not be British trucks. And that's because the European companies give their drivers money, whereas a lot of the British ones don't. So it's kind of an industry problem in terms of working conditions and things like that that's been coming for a long time. But it is funny because it's in the public eye, and obviously it's getting a lot of attention from the tabloid newspapers and such like. But there are huge problems with the shortage of scientists and engineers. Like, we've had massive issues with the shortage of scientists and engineers for many, many years. And it's one that we're really struggling to get to grips with. So, everything from lorry drivers to professional engineers, anything that basically, it requires some qualifications, requires some skill, we've got a shortage of at the minute. And there's a few things there that are driving that. And, I won't say the B word because that is part of it. But we had a shortage of engineers before, way before there. I think there's a combination of, in the West and in the Western world in general, and a lot of countries now, not even in the West, we've got aging populations. So, all the baby boomers are coming into their pension age. They are dropping out of the working population. So we've got, despite having relatively flat populations or maybe even slightly growing, we've actually got a shrinking workforce. And that is one thing that a lot of people have missed. So the shrinking workforces that we've got, contributing a lot to labour shortages in different areas, plus lots and lots of supply chain problems and disruption. Obviously, COVID caused a lot of technology stuff to really take off, so that's created demand, but issues shutting factories down and such like. And wow, it's a perfect storm at the moment. So I think what we'll see, there's obviously some fairly short-term things that are happening. If you tried to buy anything with electronics in recently, you will have found it's on a massive lead time, or you can't get it at all, or delivery dates are moving all over the place. What we're going to see is a lot of investments in more autonomous systems. So that's kind of in the short term not actually going to help the problem, because autonomous systems, going to have electronics and robotics and things like that in these things, but more autonomous systems in warehouses, so warehouse robotics. There's a real political will now for stuff like self-driving trucks and cars to really get on the road. So I think you're going to see a focus and a clear political will to start pushing things like that through. So more automation, and that could be also process automation inside businesses, so we can kind of free up people to do stuff that only people can do. I think there's going to be an awful lot of investment all over the world in that sort of space. And, what's great about that for people in the EV space, or perhaps not so great depending on your point of view, but the positive of that is, it's the same skills, the same fundamental technologies. There's lots of opportunities in that. So robots need motors, they need power electronics, they need drives. If it's a mobile robotic system, it needs a battery pack. There's lots and lots of things in that. Obviously sensor systems and stuff like that. So going to be a huge amount of stuff going on with autonomous systems, I think, in the next few years. We will see, things like further down the supply chain, we've got the semiconductor crisis. That's a combination, again, of a number of factors, but basically growth in demand for semiconductors in the last few years has far outstripped new capacity that people have been putting in. And we've now got semiconductors in everything. So LED light bulbs, are one really easy example that's in front of everyone. So inside that LED light, you've got LEDs, which are made in a semiconductor process. There's probably some sort of power supply type signal stuff in there. It could be a little microprocessor. There's going to be quite a lot of stuff in there. Quite a lot of electronics content, even in a simple light bulb, right up to high efficiency electric motor drive systems, electric vehicles, obviously, robotics, which we just talked about, IT equipment, servers, on and on and on. Could go on about it, but the semiconductors in absolutely everything. The demand has absolutely well and truly outstripped supply. And what we'll see now is there will be some investments in new capacity in the semiconductor world, and that's happening, and we're starting to see people kind of go to more local supply chains even. So investments in Europe. So Intel are talking about putting some big investments into Europe. And others, including one of the businesses that I've been working with, talking about a big investment in a semiconductor business. So there's lots of stuff going on, putting new capacity in. There's also some really interesting new technology as well coming in the semiconductor field. So we talk about wide bandgap devices or compound semiconductors. So, multi-material devices. I didn't really realize why a compound semiconductor, if I'm honest, was called a compound semiconductor. When I think about it, I think, you were really silly. A compound, as in like lots of elements together, rather than a single element. So a normal semiconductor is made out of silicon as a single element. A compound semiconductor is made out of something like silicon carbide or gallium nitride, which is a few combined together. Hence, it's a compound. Now, it took me about 3 years to work that out. So hopefully someone else has got that. I believe they used to refer to these as multi-material in the past, but compound's a bit more of a kind of cooler sounding term for it. Now, the thing with compound semiconductors is they are really hard to make. So the manufacturing technology in them is very, very difficult. The actual product design and stuff like that is also very difficult. But they are, super efficient, really, really good in energy systems applications. So things like drives and DC-DC converters and solid-state transformers and grid-connected electronics are all going for compound semiconductors because they're so much more efficient than conventional silicon devices. So, because these things are so hard to make, actually far, far, far from being commodities, actually these things are really super highly specialized in both their design and the manufacture. And the new capacity for them is going to take many, many years to come through. So I think, to be fair, we're not going to see the short-term issues that we're seeing now go away on the semiconductor side, anytime soon, really. It's a space to watch very, very carefully. And if you're designing new products like motor drives and things like that, the semiconductor content is something to keep a very, very close eye on. You want to be thinking about the availability of components. You want to be thinking about the supplier, what they've got in terms of planned new capacity, and what they've got in demand in other applications. So there's an awful lot going on in that space. Obviously, widespread adoption of technology that we've got to enhance our lives, from every different aspect that I've been talking about. So, it's going to be a really exciting time in that space as well, and that feeds directly in, because if you want to buy an EV at the minute, it's quite difficult because there isn't a lot of supply. That's partly battery supply chain issues, but mostly semiconductor issues, and that's also causing problems with conventional vehicles. So anyone who's tried to buy a car at the moment will know it's pretty difficult in terms of getting availability of new vehicles, and that's a lot to do with semiconductors, let alone PlayStations and all that sort of stuff, where they've also got issues as well. So what have I got coming for you then? So that's my kind of ramble and bamble, and welcome back, and here I am. So hopefully there are still some people listening and you haven't turned off yet. I have got some really, really good stuff coming. So I've got some amazing interviews with industry experts in motors, electronics, battery technology, and sensing systems. So some really, really good stuff coming. If you look back at the past episodes, you'll have seen we've got some, fantastic people on there. Actually, because of the length of time we've been doing this, some of those have moved from one role to the other. So interesting past episode, if anyone checks it out, was Isabel Sheldon. So she was at the UK BIC, so the Battery Innovation Centre. She's now with the company I mentioned before, British Volt. So, if you want to find out some more about Isabel, have a check out of that episode. We've got some more interviews coming with those kind of industry experts, so people absolutely at the top of their game. I'm also offering a limited number of slots for people to be interviewed, so about the work that you are doing. So if you're a small company, an SME, you want to get the word out about what you're doing and, help to get in front of more people, get in touch, because I'm going to be doing some episodes with people just like you. So if you want one of those slots, I've got basically a number of interviews lined up over the coming months, but I have got some slots that I'm keeping open for people. So if you want one of those, get in touch. And we'll try and work it in. It's got to be technology, and it's got to be at the cutting edge in the EV or the autonomous vehicle space. That's basically it. But whatever you're doing in that space, we'll be really, really interested in hearing from you. So that's it. That's all we've got time for today. Don't forget to hit like and subscribe. Make sure you get the new episodes as soon as they're released. It will be coming more frequently, and I'm really, really sorry again for the length of time it's been since I last put an episode out. There's been an awful lot going on. There'll be an episode, maybe every week-ish, maybe a little bit longer. Don't want to set any exact limits on that because I do have quite a lot of other things going on, but I'm trying to make these on a fairly regular basis. We've got a few ready already to put out. We've got some others lined up and coming. So yeah, don't forget, like and subscribe and you'll get one. Also, if you want to leave me a rating or a review or a comment, you'll see. If you're looking at this on the new eTech website, you'll see we've got some amazing reviews that people have left in the past, but those reviews really help to get the podcast in front of some more people. So, that helps get the show out there and in front of some more people. So thanks again for listening. I really, really look forward to talking to you again soon.